to design on a model, we need to basically put together all the results so that we can have a summary of them instead of looking at the values that you get on these AUCs and performance on the validation. So you can of course do this in Excel. It's a lot easier to just copy and paste those values and take a look at it. But let me do it in let's call it results. We can put a data frame together, and that data frame um, is going to have a few things. We can have, first of all, let's do a variable called model, and that's going to be the type of model that we have. We have three. Model 1, which is the full model, and we have model 2, which is the stepwise. We call it step M2. And we have model 3, which was a step step M3. So this is basically what we have is a data set with the models. Now we need to have actually the AUC values. So let's call these AUC of training, and we're gonna just put the values in there. So that's R1 dot train $ AUC, and we're gonna combine that with R2 for train AUC and with R3 dot train and the AUC value. Those are the values for the training data set. The AUC, we need also the values for the validation, and those are going to be R1 dot valid $AUC, and I want to combine that with R2 dot valid AUC and also with R3 AUC. So we have the AUC values on the validation, and finally let's put there the degrees of freedom as well. So let's call it DF. And I just looked at this. The degrees of freedom for model number 1 was 86, and the degrees of freedom for model number 2 was 10, and the degrees of freedom for model number 3 is 22. So those are things to consider. If we want to take a look at the results for this, these are the results summarized in a table. Again, like I said, you can always do these in Excel if it is easier for you. But we generally want to select the model according to the validation performance. So two things to look at. The model that performs the best is model number 3 in terms of the AUC value. So it separates better the responders from the non-responders. Now the difference is not too big in performance. So we also have to check the complexity of the model in terms of degrees of freedom. So you know that the more complex a model is, the more difficult it is to, the more time it takes to just to fit the model or to make predictions. In this case, we don't have too many observations. So we have already, let's think that this is what we call our champion model. So in this case, our champion model is model 3, and this is the performance of the model. So basically the performance is we have an AUC, or that is an area under the curve, of 62%, and the complexity, so we have 22 degrees of freedom in the model. So having said that, this is basically one way that you can check which models performing the best. Of course, you want to do these with all the models that you choose So this is only looking at the logistic regression. I want you to, whenever you're doing a model, to keep track of how the models are performing so that it is easier for you to select the model that is the best performer. So this is always a good practice in selecting your best model. So in this case, we're selecting model number 3, slightly more complex, and model number 2 has a slightly better performance on the validation.